Howdy folks, John here from rchelicopterfun.com. Today we're looking at a new addition to the RC workbench, the Hantek DSO5102P digital storage oscilloscope. I consider this one of the best valued entry-level benchtop digital scopes on the market right now. Perfectly suited for beginners and hobbyists. So if you've been considering getting your own first digital oscilloscope, as I have been for a couple of years now, or you already have the DSO5102P on your short list, hopefully this video will answer more questions and help you out in your own scope quest. I want to thank Banggood for sending the scope so we can all have a look at it together. As usual, I've links below in the description to the scope, along with a few others that were also on my short list. Let's get to the review. As I said, I've been looking for a decent entry-level digital scope for a while now. I've had a 60 megahertz analog scope that some of you will have seen in a few of my videos. I've had that for many years, but with these new low-cost, under $300 Chinese scopes, with all the new features and ease of use, using that old analog scope was getting painfully tedious. Not only was I getting tired of counting all the points on the gradical to calculate the voltage and time frame, and then having to convert it to frequency, it's a heavy bugger and just took up too much space. You know, I'll mention a few of the other scopes I was also seriously considering at the end of this video if you want to check them out too. But this Hantek is hard to beat for the sheer value it offers. It wasn't too long ago a digital scope like any of these entry-level ones with the specs and features they have would have cost well over $1,000. Thankfully the price, along with the usability, is at a point now that hobbyists, do-it-yourselfers, first-time scope users, and students, we can all get a proper scope for home use for the same price or even less than a higher-end multimeter. It's amazing. Hantek itself has a solid name and reputation in the Chinese oscilloscope market, along with the other two brands I was considering, Siglent and of course Rigol. This one is one of three in Hantek's 5000P series of entry-level scopes. This is the 100 megahertz version. They also have a 70 and a 200 megahertz version. I'm not going to get into all the specs, but the main ones are all of them have a sample rate of 1 gigasamples per second and a 3.5 nanosecond rise time and up to 40 kilopoints of memory. Now, at a maximum 40K points of record length, these are far from what would be considered deep memory scopes, but it's entry level and I don't need deep memory for what I use my scope for in the hobby and as a DIYer. If you want more memory, a couple of the other scopes I'm mentioning at the end of the video would be better choices. However, consider that large memory record length really drives the cost up. That again is why you won't find deep memory scopes in this entry-level price segment. Now, one thing neat about the DSO5000P series is they are hackable. Now, there's information online, you can look it up yourself, but if you got the 70 megahertz version, you can upgrade the firmware to bring it up to 200 megahertz. I got the middle one just because the value was so good. You can usually get this one for the same price as the 70 megahertz. The general rule of thumb when selecting a scope's bandwidth is to pick it at least 4 times higher than what you measure. 5 times would be ideal. Now you can certainly measure higher bandwidths, but you lose attenuation, so your voltage will drop as you're measuring higher frequencies. So the general rule of thumb is 4 to 5 times. And rarely do I even get into the megahertz frequency range. I'm usually always checking stuff in kilohertz. Now, another great thing about this scope was the display size. It's a proper 7-inch 800 by 480 high-resolution anti-glare display. Many entry-level scopes are only 5.7 inches. More are coming now with 7 inches, so that's not that big of a thing anymore. But you know, a nice big display is awesome. Scopes, if you don't know, if you're still watching the video, chances are you know what an oscilloscope does. They primarily measure voltage changes over time. You've got your voltage scale on your y-axis and your time scale on the x. And unlike a multimeter where you can just take voltage readings, this will record those voltage readings as they change, and you can see that graphically. And it just helps you debug stuff. It helps you understand how circuits work. You know, I really fully didn't understand how PWM signals worked in receivers going to the servo until I actually used a scope to see the waveform. And same thing with S-bus. You know, until I actually saw how the packets are arranged, and then zooming in on a packet, which this scope has no problem doing. It's very cool. Oscilloscopes are fun to play with, and these new digital ones, they've got so many features. They're so easy to use that really anyone could pick one up. If you can use a multimeter, you can use one of these. Now the scope itself, it's a good looking scope. All digital scopes look very similar. You know, you've got your vertical adjustments, your horizontal, your trigger. You've generally got your main menu selection up here. And of course it's a 2-channel. There's our 2 channels of input. And they've got nice function buttons that line up well to the graphical selections that come up on the side of the screen. It's got split screen. All scopes have these little outlets, basically a 5-volt, 1 kilohertz square wave. That's how you calibrate your probes. And we'll do one just to show you what that's about. You know, it's a good looking, like I said, good looking scope. You know, I kind of like this teal color. The cooling fan is there. It's got lots of ventilation throughout. The other nice thing, most scopes are like this, but it's something to look for, is your power inlet is recessed, so you can put this right up to the wall. The power plug isn't going to be preventing you from putting it right to the wall. There's a nice little carrying handle, and then it's got rubber feet at the back and these 2 little flip down feet, so you can have it on your bench and it'll sit at an angle so you can view the screen, just to improve screen viewing angle. And it's got a USB port that you can plug a USB stick into, and that allows you to record or take photos to download waveforms. Simple, very simple, 1-button ordeal. It's also got a USB input at the back. This is to either update firmware or record right onto the computer. Of course, it's universal voltage. It's shipped with a European plug, the C13 on the end, and an adapter for North American market, but it's not grounded. And that is a big fail. So, you know, I'm just using obviously a North American plug, which is grounded, but for safety reasons, you generally want these grounded. Now, also on safety, just mentioning it real quick, if you've never used a scope before, one of the biggest things that beginners learn the hard way is your probe or earth ground. And it can cause problems if you're hooking the grounding point up to something that's not at earth ground. You can short it out. So unlike a multimeter, which is floating, it doesn't really matter if you've got the negative at a voltage potential. When you're measuring circuits with these things, you know, if it's a battery powered circuit, no big deal. But if it's hooked to a power supply or something that has a grounded source, yeah, you can cause problems. And what else do we get? So we get 2 probes, and they're decent. They are the PP150 probes. These are good up to 100 megahertz. And we'll calibrate one here, just to show you what that's about. And it comes with a manual. And just another thing to be aware of, there's a selection on here. A 1 times and a 10 times. It's divided by 10. Generally, you always want to be in the 10 times scale, and that's what's nice about these digital scopes. You can select that so the values are reading correctly, but when you're in that 10 times scale, you can read higher frequencies, and it even says that on here. In the 1 times scale, it only works up to 6 megahertz. In the 10 times scale, it'll work up to 100 megahertz. Input voltage, it's saying it can go up to 600 volts. Yeah, I wouldn't want to be passing 600 volts through that, and I wouldn't want to be putting 600 volts into the scope. You can certainly measure line voltage though with it, no problem with that. So what are we getting here? We've got, it's just a warranty card, maintenance record. Yeah, I don't know what kind of value that is. Hantek certification, past QC. This little disc has got the USB software if you want to hook it up to your computer, and it's also got the instructions, and really good instructions, by the way. 71-page manual. In fact, I've got it up on the screen here. Let me just bring it up. I'll pan up. Hopefully you can see this. I don't know if you can see that. This is probably zoom in. But yeah, it's just a decent manual. if you don't know much about scopes, after reading through this, it'll give you a really good basic operation of the scope, and it's good translation. It's not like the usual unrecognizable Chinglish. You know, someone did a really good job with it. So great manual, and that's on the disc. And what else do we have in here? Packing list, what it comes with, the scope, the two probes, power line, which is useless, the CD, the warranty card, manufactured certificate, oh, and a USB cord somewhere around here. Oh, there it is. And with all that, let's power this thing on and calibrate a probe. Okay, I've got it plugged in. I'll power it up. See how long the boot time is. It's about 10 seconds. I've already timed it. And there we go. Just gonna turn this off. Reset that, and we will plug our probe in. So these probes, they have a little adjustment pot in them, which is basically a variable capacitor, and that's how you calibrate the probe. That's just a BNC connector. And now the other end of the probe, I should probably unravel this, but so here's your ground, and this is your probe end, just sprung loaded. So we'll put our ground on our ground pin and attach the probe. Okay, so there's our square waveform, and we'll just, I guess that looks pretty good. Zoom in a little bit more. So here's our adjustment tool, and as you can see, this is overcompensated, this big tick, so we want to turn that down. We want to get a square wave on here. Ooh, going the wrong way. Ooh, that's undercompensated. Getting pretty close there. We'll just zoom in. No, looks pretty good. So that's all there is to compensating a probe. Now we'll go over some of the features on the unit really quick. If I went through them all, this would be a few-hour video. It's just amazing. Even an entry-level scope, all the cool stuff they can do. Okay, I've got both channels plugged in. We're looking at a couple of waveforms. These are just being generated by one of these cheapy little waveform generators. They're around 10 bucks. They're a kit. Well, at least this one was a kit. I might do another video on that. I bought 2 kits, so maybe I'll do another video on building up. But regardless, these put out a square wave along with either a triangle or a sine wave, which we can see on here. And you can set the frequency anywhere from 1 hertz up to 1 megahertz, as well as the amplitude. You can change the amplitude of the wave, at least the sine and the triangle wave. You can't change the amplitude of the square wave. So if you've never used a scope before, one of the really handy things with digital scopes is they will set everything up for you if you don't know how to zoom in and out and get your time scales set. You know, these knobs on your 2 channels, this will select your vertical position. So this is basically selecting volts per division, and same with channel 2 there. And what's nice, they're both separate, so you can independently set them. You can move their positions relative to each other, up or down. And then your time scale, which is the horizontal scale, you can zoom in, or sorry, zoom out, or you can zoom in on the waveform. But if you don't know what you're doing, if you've got something really screwy looking here, you know, you turn it on, that's what you're getting. You can just hit this auto set, and this scope will select the best voltage and time scale to at least get you in the ballpark. And then of course you can move things around as you want. The other nice thing is the triggering, but if things aren't triggered properly, the waveform will be dancing all over. You can just hit set to 50. It'll bring the triggering point to the center of your waveform, and of course you can also dial it up and down. And there's triggering menus. It'll show where it triggers. There's so much that this will do, but we won't get into all that. Just to show you what the channel menu looks like. It's got the coupling type. You can limit the frequency to 20 megahertz. That just eliminates a lot of noise when you have that selected. And you can have coarse or fine voltage adjustment. This is where you would change your probe attenuation if you had it at 1 times, but we've got it at 10 times. To get out of the menus, you just push the F0. And you can see, I don't know if you noticed that, but all the function buttons, they line up really nice to every one of the selections in the window here. You know what I'm gonna do? I'm gonna flip these feet down. There. Well, we might be able to see it a little bit better. Yeah. Oh, and it's also got a split screen, which is neat. So this window here is showing what's in the big window. Bring up both waveforms. And then if you wanted to capture the waveform, so hit capture, and then we can zoom right in on it. Or zoom out. Some of the other functions it's got. The utility function, you can look at system information, firmware update, you can save the waveform, do a self-calibration. That's recommended when you first get it. It takes a while. It takes about 10 minutes to go through calibration, but you don't have to take it in to get it calibrated. They do it all automatically now. This button will take you to the next screen. We've got the keypad beep on or off, so if you wanted to have beeps, you could. That drives me crazy, so I've got it turned off. There's several different languages you can have it in. You can have the background at different colors. I've got it at the dark or the black right now. It doesn't look it on the display or on the camera, but it's a nice dark gray. You can have green. You can have this purple, kind of a yellow, pea soup green, or blue, but I like the black the best. You can set the time, system status, and on page 3 you've got pass-fail menu, a recorder, filter, printer configuration, and then an option screen. Lots of different settings there. Display settings, you can have your waveforms as vectors or dots. Persistency, I've just got it set to auto. DSO mode, contrast, you can dial the contrast up or down. Whenever you hit a selection that is adjustable, this little green light comes on and you turn this knob to adjust it. And then page 2, the gradical lines, you can have them off, dotted, or full. The intensity of the graticals, you can turn it up or down. Refresh rate, I've got it set to auto, and the waveform intensity, again, you can dial that up or down. So lots of adjustability on this thing. And again, this is an entry-level scope. You know, the higher the scope goes, just the more they do. And this just gives you a really simple overview. You've got an acquire menu, real-time or EQU. You can peak it or average it. You can have the average, how many points you want to take. There's our memory depth. We can only go to 20K when we've got 2 channels because each channel is taking up memory. So if you want deeper memory, if you want maximum memory, you can only use 1 channel. But for a beginner scope, more than enough. Horizontal menu, we didn't look at that. You can look at the major, minor window, set, clear all, page 2, time division, coarse or fine, horizontal position, coarse or fine. I actually like coarse. You can move it a lot quicker. And measure, that's one of the best features. You don't have to calculate anything, you don't have to count. You know, we're at 2 volts per division, so you could count on all your graticals to figure that out, but it gives you the voltage right there. Peak to peak, 4.16 on our sine wave here. If we were measuring our second wave, it would be in the blue, and this would all be blue instead of yellow, showing the frequency. If we turn up the frequency, you'll see the frequency getting higher and higher to 57 kilohertz, or we'll turn it down so it automatically shows you all that. And that's what's so cool about a digital scope. You don't have to dick around. So we'll get out of this, and I'll just do a cursor real quick. You can select time or voltage or track, and this way you just select your 2 points, your starting point and your end point, and it will either give you the time output or the voltage output. So you can do all that. So many ways to check what's going on in here instead of counting graticules. So if you've had an old analog scope or you've used one, these are so much easier. And maybe one of the best features for a beginner is this help menu. Anytime the last menu where you were in, or the screen, geez, is that showing up? Probably isn't, but it gives you a full help tutorial on whatever you were doing. So if we were in the measurement screen and we hit help, it'll tell you all about how to use the measurement functions. You know, it's page 1 of 4, page 2 of 4, page 3 of 4, and to exit you just use one of your function buttons. Another cool thing that all modern day digital oscilloscopes have, even these entry-level ones, is a fairly decent math menu. Now on my old analog scope, I only had one math function, and that was channel 1 plus channel 2, which is what we're doing right here. And this new purple waveform is the combination of the sinusoidal channel 1 with the square of channel 2, and that's what we're getting. But you can also subtract waveforms, you can multiply them, you can divide them, and this has also got an FFT math function, which is basically giving you a frequency constant of a signal. If you don't understand FFT, hit the help. I've never had that function before. Gonna start playing around with that more. It'll give you different windows, how you want to display the FFT signal. And you can even zoom in if you wanted to. Another thing I should mention is just how nice all the buttons are. You know, they're a nice soft silicone rubberized button. All the encoders are really smooth. They're a 12 position encoder. This one's got a push button. All the potentiometers are very smooth. They also have a push button to zero things back out. And a few of the buttons, as you can see, are backlit, but just a really nice layout. And this is pretty standard layout on all these beginner scopes. Basically, if you can use one, you can use them all. If you've really messed everything up, you can't get anything to work, there's also a default setup, and it brings everything back to the default settings. I don't want to touch that because I've got a few in here I've already set that I don't want to change. Wow, let's do it. What the hell? And it takes everything back to its original settings. We'll do the auto set here, see if we can bring our waveforms back. There they are. I'm just going to dial up the amplitude, bring this down. There. Powerful scope for a beginner, but easy to use. So the other scopes I was looking at, in case you're curious, I'll put little photos of them up in the top corner here so you can have a look. They're all 2-channel. They're all high resolution 7-inch displays. And the first one is the Siglent SDS1052DL. It's only 50 megahertz. Again, would have been fine for me. As far as its sampling rate though, it's only 500 megasamples per second, not 1 gig. So half the samples per second, and it has up to 32K points of record length. So even lower than this one. And it's roughly the same price as this one. So just, it didn't have as many features, but Siglent makes a great scope as well. It looks very similar. So you can check that one out as well. Again, it's around 250 bucks. The Siglent SDS5102CML, it's 100 megahertz, so same as this. It's got 1 gigasamples per second, so that's good. It's got up to 2 million points of record length of memory. So a lot more memory with it, and it's around $300. So if you needed more memory than 40K, that might be one to look at. And then the cream of the crop, and if I needed a long record length, this is a really good scope. It's the Rigol DSO5102P, 200 megahertz bandwidth, so fastest of all of them. 1 giga samples per second, so same, but it is a deep memory scope. 24 million points of deep memory on it. So it's by far the best scope of the bunch as far as memory goes, but you pay for it. It's around $360, so $100 more than this one. And any of these, along with this Hantek DSO5000 series, you know, they're not the only good entry-level 2-channel scopes, of course, but they are the ones that ticked off the most boxes for my specific needs. This one has more than enough features that I need, and the price was, you know, it's the best priced one of all of them, the best value as far as I'm concerned. If you have experience with any of these oscilloscopes or any other entry-level digital oscilloscopes and want to share your thoughts in the comments to help others, please do so. You know, the entry-level digital scope market is becoming fairly saturated, and it's getting hard to navigate for newbies. Cheers, folks. Thanks for watching, and we'll see you next time.